I recently went on vacation to Singapore. On my way there, I flew westwards from San Francisco to Singapore on United Airlines Flight 1, serviced by a Boeing 787-9. It took 17 hours. On my way back, I flew eastwards from Singapore to San Francisco on United Airlines Flight 2, serviced by a Boeing 787-9. It took 15 hours. Why the difference? The answer? Jet streams. A jet stream is simply put, some air that's moving faster than the surrounding air. These jet streams are caused by temperature differences between different parts of the Earth's atmosphere. This temperature difference is caused by the sun heating the Earth's equator more than its poles. When warm air meets cool air, the warm air rises while the cool air sinks. This air movement is what we call wind and forms the basis of jet streams. But hold on, if warm air rises while cool air sinks, shouldn't the air just move towards the poles? Well, yes, but that would only be true if the Earth was stationary, which we know is not the case. The Earth turns on its axis once every 24 hours. Now, two important things to note about the Earth at this critical juncture. Number one, the Earth spins eastwards, or counterclockwise from the perspective of the North Pole. And number two, the Earth is a sphere. Sorry, flat earthers, you're not going to like this video. Now, because the Earth is spinning eastwards, the air that makes up its atmosphere is also spinning eastwards along with it at a uniform angular speed. That is, air, irrespective of where it is over the Earth, travels through the same angle per unit time. But this means that the air near the equator has to be moving at a faster linear speed than the air near the poles, just because the circumference around the Earth is larger near the equator. If it helps, this in blue is one revolution, 360 degrees. This in red is also one revolution, also 360 degrees. But if we were to lay the blue and red lines flat, we'd see that the red line is longer than the blue. The red line represents the path that the air near the equator has to travel, and the blue line represents the path that the air near the poles has to travel. The air is traveling through these lines in the same amount of time, so the air following the red path has to be moving faster since speed is just distance divided by time. Increasing the distance while keeping the time the same means that the speed must be faster. As the warm air near the equator moves towards the poles, it keeps this extra eastward speed and so has a faster relative speed than the Earth below it. The closer that the air gets to the poles, the faster its relative speed becomes. So, as the air moves towards the poles, it's also blowing west to east. This movement is called the Coriolis Effect, and thus the direction of the jet streams are determined. As you can imagine, it's a lot more efficient when planes are able to fly in the direction of these jet streams, and so that's why it's faster to fly east.